Okay, good evening, everyone. As you already know, my name is Rahul Kumar, and I am delivering the lecture of engineering mechanics. And in this week, I will discuss about the dynamics of particles and rigid bodies. So let's move to the one note. Okay, so in our dynamics syllabus, we'll talk about these two things. So, so the first is kinematics, and in this is actually the study of the study of geometry, the geometry of motion. Geometry of motion, for example, displacement, velocity, acceleration, etc. And the second class is called kinetics. Okay, and this is the study of the relation between forces acting on a body, comma, the mass of the body and the motion of the body. Okay, the motion of the body. So this is called kinematics and kinetics. Okay, so first I will discuss kinematics of particles. Okay, so our first topic is kinematics of particles, and I have already talked about this. What are particles? So in this, we usually we will neglect we will neglect any rotation, okay, because I will talk about particle, okay, not rigid body. Any rotation about their on center of mass, center of mass. Okay, so in the kinematics of particles, first I will discuss what rectilinear motion. Rectilinear motion. It is also called one-dimensional motion. One-dimensional motion. Okay. So what are rectilinear motion? Can you tell me?
Motion in a straight line, sir.
Yeah. So a particle moving along a straight line, okay, are called, okay, so called what? Rectilinear motion. Rectilinear motion. So in this study, these are important variables. What are variables? Can you tell me?
Position, speed, acceleration.
Yeah.
Time.
Okay, so first is time, second is displacement, okay, third is distance, and velocity, speed, acceleration. Okay, so these are variables in rectilinear motion. Okay, so first let's discuss position. Position. Tell me what is position? I'm talking about rectilinear motion. Okay, so tell me what is position? Okay, so
Distance from the reference bottom, reference point.
distance. Distance. You're talking about distance. So
Yes, sir.
suppose this is the reference point. Okay, and there is an object, and it is
So
traveling
where
like
it
this.
is to
It is
point.
traveling like this. So this is called position of this point A. Tell me. No. Okay.
ये rectilinear motion था क्या sir?
Huh?
Location in space.
Yeah. You're right. Actually, in the straight line motion, you can tell. Yeah, you can say that distance. Okay, but actually, distance is different categories. So I will not say that the position is the distance. Okay. So the main definition is in a straight line motion, it is correct. Okay. But the one more problem is, position can be negative and positive also. But you are saying that the distance, okay, but the distance cannot be a negative quantity. So that is not appropriate. Okay. So the position is actually the coordinate, the coordinate, okay, the coordinate of a particle or any particle of any particle about a reference point. Okay, so when I talk about straight line motion, suppose I am assuming that this point O is the reference point. Okay, so suppose a particle is situated at point A, and the distance between O and A is some distance. Okay, so suppose the distance is D. So the position, I mean the position of A, I mean the coordinate of A is called the position of point A. But suppose, and if I assume that O is the reference point, then in this direction you have to assume it is positive. Okay, and suppose the particle B is situated here, and the distance is something d2. Okay, so this is called the position of point B, but here the direction is reverse. So the position, or you can say displacement, both are same, position or displacement. Okay, so since it is a vector quantity, it will be negative and positive both. Okay, so let's talk about velocity. Okay, so velocity is actually of two types. The first is called average velocity. Tell me what are average velocity? And second is instantaneous velocity. What is the difference between these two?
Average velocity is the uh, average of velocity at 2 points. It doesn't depend how large the distance is. Whereas instantaneous velocity is velocity when we take the limit, very small limit.
So the first you are saying that the average the velocity, I mean the average of the velocity at 2 point, right? Hmm?
Yes.
Oh, so that is not correct actually. Uh, Someone else?
It's the total distance traveled by the total time taken.
No.
Every velocity is the average of whole velocity at every point of time.
No. Actually, average velocity is defined like this: change in position divided by change in time, or you can say time interval. Time interval. Okay. So what does it mean? Suppose if I talk about a rectilinear motion. Okay. So let's take. Okay. Suppose it is a reference point O. Okay. Uh, Suppose at time t, the particle P situated at position x. Okay. Now it is taking time t. Now after time t plus delta t, particle reaches at point x plus delta x. Okay. So it is the initial point and it is the final point. So what is the change in position? Change in position is what? Delta x.
Delta.
Yeah. And the time interval, the gap, what is the gap? Delta t. Okay. So the change in position will be what? X plus delta x minus x divided by t plus delta t minus t. Okay. So t plus delta t minus t, that will be what? Delta x divided by delta t. This is called average velocity. Okay. So don't confuse between average velocity and average speed. Okay, because average velocity is a vector quantity. And remember one thing, here I am writing vector quantity. Okay, so don't forget this. Okay, so what is the instantaneous velocity? Someone told me that, suppose I am reducing the time gap. If I am reducing the time gap between point P and Q. Okay, so what does it mean? It means that I am I am trying to identify a fixed point. Okay, I want to find the velocity at a certain time, at a fixed time. If suppose if I am trying to reduce delta t. Okay, if I am trying, position suppose point P is here, point Q is here. Okay, uh, if the time interval between P and Q is delta t, and if I am reducing the time. Okay, since you cannot reduce the time, but suppose you are very close between point P and Q, what will happen? Point P and Q will come closer. Okay, so there will be point when P and Q will be coincident. Okay, so at that point of time delta t will become 0. Okay, so instantaneous velocity is defined like this: instantaneous velocity is defined like this: limit delta t approaches 0, what? Delta x divided by delta t. And we know that from the definition of limit, or you can say from the definition of derivative, we can write dx divided by dt. So this is called what? Instantaneous velocity. Okay, so if you want to interpret graphically, what will happen? Suppose I have a graph. Okay, I have a graph of position versus time t, position versus time t, and the particle, suppose the particle is moving like, I mean the path of the particle is like this. Since I'm not talking about the straight line motion. Okay, so I'm just giving an example, because the concept of instantaneous velocity and average velocity is same everywhere. Okay, so it doesn't matter. Suppose the particle is at point A, okay, and after certain time the particle is at point B, and the position of the particle is what? Suppose R A, okay, and after t plus delta t, wait, after t plus delta t, the particle's position is B, and in the vector form you can write RB. Okay, so if I connect the point A and B, what will happen? Is it called delta? Is it called delta R? Tell me from the definition of vector. Tell me. Hello.
Yes, sir.
Yeah, is it called delta R? That is called what? Change in position. Okay. So here you can see that the average velocity, and suppose it is a delta R, and if you divide delta R divided by delta t, what will you call it? Average velocity. Okay, you can see that, so if it is a delta R, then here you can form a triangle. Okay, here you can form a triangle, right? Okay, so because yeah, you can form a triangle. So if you divide delta R by delta t, you can see that it is a connection. I mean, it is a displacement between A and B, and you are dividing by delta t. So it is called what? Average velocity. But when you want to determine the instantaneous velocity, here you can see that it is actually a tangent. It is actually a tangent between x and t. So what will happen if delta t approaches 0? Then here you can see that A and point B are nearly coincident. Okay, so when you try to connect point A and B, that point is nothing but a tangent point. Okay, so the slope, I mean the slope of the tangent is nothing but the instantaneous velocity. Okay, but here the average velocity is what? Here you are subtracting the position between A and B, then you are dividing what? Delta t, time interval. Then it is called what? Average velocity. So that is the difference between instantaneous velocity and average velocity. So don't confuse, okay? Because itself it is saying the instantaneous velocity, which means it is talking about the velocity at a certain time. But the average velocity, it is talking about the velocity at a certain interval. I mean, there is something finite time difference. Okay, is there any doubt? Tell me.
No.
Yeah, so I talked about average velocity, instantaneous velocity. Let's talk about distance. Okay, so if the motion is rectilinear, then the distance d is nothing but the what? The
Time
distance,
into displacement.
no, the distance d, suppose the particle reference point is O, okay? So suppose the particle reaches at point
Display.
this, then it is moving like this, okay? So you have to add every, I mean, you have to add, what can you say, absolute. You have to add by absolute meaning, which means if you are assuming positive in this direction, then if the particle is moving in reverse direction, then you have to take what? Mod. Okay, so this is the definition of, I mean, physical interpretation of distance. Okay, because the motion, if the particle is in rectilinear motion, then sometimes maybe if the particle is moving in this direction, then you have to add this distance, and if particle is returning, then you have to add that also. Okay, so at every interval of time you have to add each distance. Okay, so I mean distance is nothing but the length of the path, length of the traversed path. So that is the distance. Since I am talking about the rectilinear, that's why I am saying like this. But if the motion is like curvilinear, okay, so the distance is nothing but the arc length. I mean each arc, the distance between the, I mean the length of each arc, okay, each arc at different interval of times. Okay, so this is the distance. Okay, now let's talk about the speed. Okay, so speed is in the case of speed, it is also a concept of what? Average speed. There is also a concept of average speed. Average speed. But in this case, the definition of average speed is something different from the average velocity. Okay, so the average speed is nothing but the total distance divided by total time. Okay, so this is the average speed, and the average velocity, I mean average, sorry, instantaneous speed. Instantaneous speed. In the instantaneous speed, one thing you can notice that I am not writing any subscript in instantaneous. You know why? I am not writing any subscript here. At the average velocity, I am writing subscript, but in the case of instantaneous, I am not writing any subscript. Can you tell me why?
So because it's a variable.
Yeah, because we generally talk about the instantaneous. We don't talk about average always. Okay, so average velocity is a very special case, because in each problem, in every problem, we always talk about instantaneous, because in the problem, okay, we have the value of velocity, I mean the velocity vector at certain time. Okay, so if they are not mentioning anything, then you can assume that it is a instantaneous velocity. Okay, so in the case of instantaneous velocity, the situation is same. What? You have to add every velocity. Okay, so this is the instantaneous speed. Okay, so let's move further.
Sir, what are the velocities we are adding?
What?
Sir, in the definition of instantaneous speed, are we adding all the
Yeah,
individual velocities?
you are actually, you are adding every instantaneous velocity. At every instant of time, you are adding every instantaneous velocity, and the summation of all those velocity, I mean it is very difficult to identify. It is very difficult to identify. But in the case of rectilinear motion, it is nothing but the what? The modulus of. In the case of rectilinear motion, the instantaneous speed is nothing but the modulus of velocity. Okay, because if the particle is moving in some direction, and suppose the velocity at certain time is like this, okay, so what will happen, for the instantaneous speed? It will give the positive value of this. So that's why instantaneous speed is nothing but the modulus of velocity v, modulus of instantaneous velocity at that certain of time, certain instant of time. Okay,
Yes, sir.
yeah, so now let's move to the average acceleration. Now in average acceleration is also like this. Okay, so it is nothing different but the what are the points? 5. Okay, so average acceleration. So in average acceleration, it is delta V divided by delta T. Okay, and in instantaneous, it is, oh, I'm forgetting. In instantaneous, it is limit delta T tends to 0, delta V divided by delta T, which is nothing but the dV by dt. Okay, so if you want to realize, you can see that A will be positive when V is increasing, okay, and A is negative when V is decreasing, which means if dV by dt is positive, which means the slope of VT diagram is positive, then A will be positive, okay, and if slope is negative, then A will be negative. Suppose if two particle, I mean the position of the particle is at point P and Q, and it is the velocity V, and the velocity at point Q is V dash, then in this case the acceleration will be positive, because I am here mentioning that the length of the vector is larger than this, which means V dash is larger than V, so that's why A will be positive. And if position of point final position of point particle is at Q, and if velocity of final velocity is like this and initial velocity is like this, then in this case acceleration will be also positive. And if here it must be V dash, okay, must be V dash, and if the particle's position is P, Q, and if initial is larger and final is smaller, then in this case A will be negative, and if final velocity is larger and initial is smaller, then A will be also negative. Okay, so that is the thing. So from above we have learned that A is what? dV by dt. Okay, and also V equal to dx by dt.
Sir,
Yeah, tell me.
sir, in case of motion from right to left, it is exactly opposite, sir.
Right to left. No, actually Q is the final position and P is the initial position.
Yes, sir. Like, but the velocity is decreasing, sir, in the second case. So I thought
In
acceleration.
this case you are talking about
Yes, the velocity is decreasing. So from P to
velocity is decreasing, but the problem is the direction is reverse. Okay, so suppose if V dash is minus 2 meter per second and minus, okay, minus a cap, suppose small v is larger, so it is plus 4 divided by suppose 2 second, then the result will be what? Positive. That's why it is a positive, because here the direction is reversed. Okay, so the sign will come into the picture. That's why the acceleration will be positive. Okay, got it?
yes, sir. Yes.
Yeah. Now we have reached at this point. Okay, so we saw that there is a two relation between A and B, V and X, and there is one more relation, okay, which can be derived like this. Suppose A is, you are writing dV by dt, and then you can also write dV by dx into dx by dt. So A will be what? Here dx by dt is V. So there is also a relation V dV by dx. Okay, so we have three relations. Okay, so suppose you have x versus t diagram. Okay, suppose you have x versus t diagram. Then if you see that the diagram is concave up, if xt diagram is concave up. What does it mean? If xt diagram is concave up, what does it mean? If, tell me, if xt diagram is concave up, what does it mean? Is it right? Tell me. If xt diagram is concave down, then what will happen? d2x by dt square is what? Negative. Concave up means what? Like this. And convex down, concave down means what? Like this. So here a is positive and here a is negative. Okay, and the diagram is, and the plot is xt plot. Okay, is there any doubt?
No.
Okay, so from these two, I mean from these three equations, now let's we will talk about if acceleration is constant. If a is constant, I'm talking about what? Constant acceleration. So if you have v equal to, no, if you have a equal to dv by dt, then you can write dv equal to a dt. And if you integrate from the initial velocity to final velocity, and you are taking t equal to initially time t equal to t naught and final t equal to t, then you will reach v minus v naught equal to a times, okay, t minus t naught. So v equal to v naught plus a t minus t naught. You have to remember this thing. Here I have assumed that a is called what? A is constant. Okay, so don't forget. I mean, if I have seen that many students has applied this equation without seeing that here whether a is variable or constant. You can use this equation only when a is constant. Okay, so suppose yeah, second equation is what? V dv by dx. Now cross multiply with dx, you will get v dv equal to a dx. Now integrate this from v naught to v and s naught to s naught, s naught, x naught. X naught to x. So you will get what? V square minus v naught square divided by 2 equal to a times x minus x naught. X minus x naught. So you will get the result v square equal to v naught square plus 2 times a x minus x naught. So it is the second equation, constant acceleration, accelerated motion. And the third equation is, suppose, how will you derive the third equation? Tell me. How will you derive the third equation? Do you know about the third relation?
Yes, sir. S is equal to ut plus half 8 square.
Yeah. So the third relation can be derived like this. As you know that a equal to dv by dt, and v can be written as like dx by dt. Okay, so now integrating both sides, so what will you get? Dx by dt equal to what? At. Okay, at plus c. Okay, now integrating one more time, so what will you get? X equal to at square by 2 plus ct plus d. Now you have to put the boundary condition. Okay, the first boundary condition is if at t equal to t naught, okay, so x equal to x naught and v equal to v naught, okay, and t equal to t, x equal to x and v equal to v. So here it is also v equal to what? At plus c. Okay, so when you put here it is a mistake, okay, because this equation is derived in one condition, that is at t equal to t0. Okay, here it is something different. Here you have assumed that at t equal to t naught, velocity at initial velocity is v naught, but here at t equal to t naught, t equal to 0, x is x naught. Here t naught can be anything. I mean, at any time you can assume at initial time. Okay, but here you have to assume initial time as a 0. Okay, I mean the reference time must be initial time, but here the reference time can be anything. Okay, so at t equal to 0, v equal to v naught, so v c equal to what? V naught. And when you put t equal to t, I mean here also when you put t equal to 0, you will get d equal to what? X naught. So now from this equation you can write x equal to at square by 2 and v naught t, v naught t plus d equal to what? X naught. So the general equation is like this: x equal to x naught equal to v naught t plus at square by 2. So this is the third equation. Okay, so let's solve one problem. Okay, then we will move further. Yeah, solve this problem. What is the answer in A part? Hello? What is the answer in A part? Are you getting my voice? Hello?
Yes.
Yeah,
Yes,
yeah.
sir.
Okay, yeah. Okay, so have you solved it or not?
Solving, sir.
Okay. Okay, so let's see. In this type of problem, I mean any kinematics problem, first you have to assume a coordinate system. Okay, so I'm assuming that the foot of the tower, the foot of the building, okay, I am putting here as a reference point. Okay, so in this direction, it is a positive x, it is a positive y, and it is a negative x, and it is negative y. And from the data, it has been given that a ball is being thrown with the initial velocity 10 meter per second. So what is the v naught? 10 meter per second. Okay, and initially initially the position of the ball, I mean, in this case it is a y naught, not x naught. So initially the position is what? Y naught, and y naught is positive. Okay, because it is 20 meter above the ground, and it is in the positive y direction, so 20 meter. Okay, and a y, okay, sorry, a y, I mean acceleration is in the negative direction, so z is what? 9 minus 9.81 meter per second square, so minus 9.81 meter per second square. The first problem is the velocity v. Pardon. So the first problem, it is asking the velocity v and the elevation y of the ball. So it is very simple. V equal to v naught plus a t. Okay, and since initially you have thrown the ball from this point, so t naught is 0. So v equal to v naught is equal to what? 10 plus minus 9.81 and t minus 0. The problem is very simple. Okay, so this is the velocity at certain time t. And the second problem is the elevation y of the ball above the ground. So we will apply the third equation, right? The third equation is what? Y minus y naught. Okay, so y naught is what? Here 20 meter. Okay, so y naught plus v naught t. So v naught is 10 t. Okay, and minus 1 by 2 into 9.81 into t square. So this is the equation. So 10 plus 20 minus 4.9 t square. So this is the displacement versus time equation. Now the second problem is saying what is the highest elevation reached by the ball and the corresponding value of time t. So the highest elevation means what?
Maximum height, sir.
Yeah, maximum height. So highest
Final
elevation.
velocity is 0, sir.
Yeah, you can also put v as a 0, because at the highest point, the ball, the velocity of the ball must be 0, because if the ball has some velocity upward direction, then the ball will rise further. Okay, and you cannot take that point is a highest point. Okay, so there is two method to solve it. The first method is just you have to differentiate this, and you have to put dy by dt equal to 0, and the second is you have to just substitute v as a 0. So smartest way is put just v equal to 0. So 10 minus 9.81 t equal to 0, and you will get t equal to what? 1.019 second. Okay, so the highest elevation is what? So just you have to put at the place of t, you have to put 1.019. Okay, and you will get, what is the answer?
25.1.
Yeah, 25.1. 25.1 or 251? Could you please verify?
25.1.
Yeah, 25.1. 25.1. And the C part is the time when the ball hits the ground. So what is the approach for this problem? So what is the approach for this? You
Putting
have to
x equal
just,
to 0.
yeah, or y equal to 0. Okay, just substitute y equal to 0. So you have to solve a quadratic equation. And you will get two values of time. The first is minus 1.243 second. So you cannot take this because time cannot be a negative number. And the second is 3.28 second. Am I right or not?
Sir, what is C part?
C part is the time when the ball hits the ground. When the ball hits the ground means what? Displacement will become 0. So that's why I have substitute y as a 0. Okay. So after that you will get the value of t. Now you have to substitute this t in the expression of velocity v because it is asking the corresponding velocity. So v equal to what? 10 minus 9.81 into 3.28. You will get minus 22.2 meter per second, and it is authentic because when ball hits the ground, the direction of the velocity will be definitely in the negative direction. Okay, now the task is draw the VT diagram. Okay, so it is very simple because it is just a question of straight line. Okay, so here suppose it is point 10. So we already know that if the equation of a straight line is y equal to mx plus c, then what? The c is the y-intercept, okay, and m is the slope. Okay, so here theta is what? Tan inverse m. Okay, and this is the value of c. So here also you can see that the y-intercept is 10. Okay, and the slope is what? 10 divided by 9.81. But here you can see that the velocity is 0 at what time? 1.019. So you can draw like this. Okay, so this point is what? 1.019. Okay, 019 seconds. So this is the VT diagram. Now it is asking YT curve. Okay, so now you have to draw YT curve. Can someone told me it is a concave upward or downward? This YT equation is concave upward or downward?
Downward?
Yeah, downward. Okay, so here you are getting two values of y. Okay, where y is become 0. So the one is where? The one is where when t equal to minus 1.243, since it is invalid, and the second one is 3.28. Since it is invalid, but still the graph will like this. Okay, so we will not draw here, but definitely we'll draw from here. Okay, and this time is 3.28 second. And what is this value? What is this value? We already got that. That is maximum height, and that is 25.1 meter. Am I right or not? Tell me.
So since the acceleration is in negative direction, here it is concave downward.
Yeah. And I have already talked about, okay, when a is negative, then graph will be concave downward. Okay. Okay.
Sir,
Yeah.
can you Can you repeat please that concave upward, concave downward concept?
Okay, here I have told you. Here I have told you that if d2x by dt square, okay, when xt graph is concave, okay, you want to explanation why concave of why d2x by dt square is greater than 0?
No, in this problem's
Yeah,
case, acceleration was negative.
yeah, not x, I mean here y, when you differentiate two times this equation. When you differentiate two times this equation means what? You have to determine d2y by d2 square and you will get it is negative value because it
That
will
means
become,
the slope is decreasing.
what?
That means slope is decreasing.
Slope is, yeah, slope is decreasing. Slope is decreasing. That's obviously that. I mean, d2y by dt square is constant because that is 9.81. Okay. When you differentiate two times, you will get minus 9.81 value. And that is nothing but the constant acceleration. In every case where the acceleration is negative, you will get the same result. Okay.
Huh.
Okay. Okay.
And
So,
if somebody throws ball downward, then
yeah, still the acceleration will be negative because when you are throwing a ball in vertical direction, the acceleration will always be in the negative direction. So in each case, the acceleration will be in the negative direction, except the case when I mean, you are playing a ball or like suppose the ball is traveling in this direction, okay, and suppose in the space, suppose in you are in some spaceship where there is no acceleration due to gravity, and you are throwing a ball in vertical direction where is something, velocity is changing. In that case, you can take acceleration positive. Okay, but since
Sir,
this is just a sign convention. Okay, if you
huh.
want to take a positive value, then you have to reverse everything. If you want to take a negative direction as a positive, then you have to change the velocity is also becomes negative because if you want this convention as a positive, then you have to take everything will be like this. You have to follow this convention only. Then you will get the same result. Okay.
okay, sir.
Yeah. So now let's solve this problem. What is the distance?
Is it 100
100,
meter?
100
Yeah, it
meters.
is
Yeah.
correct. And what is the average velocity?
0.
Yeah, correct. Good. So, so in this problem, you you can see that, and we have already know that what uh, v equal to dx by dt. Okay, and dx is v dt, and I have told you that I have told you that when you integrate vt diagram, then you will get the position at certain time. But when you want to find the displacement, when you want to find the displacement, then you have to find the area under VT diagram, but you have to take the velocity as a modulus. Okay, so if you want to determine the distance, then you have to find the area between VT diagram, but you have to take V as a modulus. Then you will get the distance traveled. Okay, so it is a very easy problem. So time is 0 to 40. Okay, so in 0 to 20, okay, what is the velocity? What is the velocity 0 to 20? I mean the area between VTT. Oh, okay. You can do that also, or you can just find the area of the triangle. Okay, what is the area of triangle? 20 into 5. Okay, that area is between 0 to 20. Now you have to find the area between 20 to 40, and that area is actually negative, but you have to take positive. So that is also 20.5. So you will get the answer 100 meter. Okay, now the second problem is the second part is it is asking find the average velocity. Okay, so this problem you can find like this. Suppose it is saying that obviously particle is moving along the straight line, and here you can see that at 0 to 10 second particle's velocity is increasing. Okay, and after 10 second particle's velocity is decreasing. 0 to 10 second particle velocity is increasing, then particle's velocity is decreasing, and at time t equal to 20 second particle's velocity becomes 0. Okay, so here the velocity becomes what? 0. Now velocity's direction is still reverse. I mean in this direction, still in this direction. Okay, after t equal to 20 second, the direction of the velocity is still in this direction, and in this direction the velocity becoming more negative. Okay, more negative and more. After that the velocity, I mean in the negative direction, the velocity is started increasing, and finally it becomes what? 0. So again it is reaching at point this, because there is a similarity. Okay, whatever it is following in this time interval, the same in this time interval also it is following the same path, and finally it is reaching at point O. Okay, that's why the displacement becomes 0. So the average velocity is also 0. So V average equal to 0. Is there a doubt?
Can you please repeat this average velocity part?
What?
Average velocity part alone. Can you please repeat, sir?
Okay. Here you have to divide into two time intervals. Okay, suppose 0 to 10 second. In interval 0 to 10 second, you can see that the velocity is increasing. Okay, and you can realize this thing in this situation also. No, in this situation not, because it is a acceleration in negative direction. Okay, suppose from the particles motion is starting from origin. Okay, and now it is saying that 0 to in between 0 to 10 second the particles velocity is increasing. Okay, up to 10 second, and after that this velocity is starting decreasing and it becomes 0. At t equal to 20 second it becomes 0 here, and you can see that the direction becomes reverse because velocity is negative here. So if the direction becomes reverse, then particle is now moving in this direction. Okay, and it is following the same history whatever it has followed in between 0 to 20. Okay, now it is going towards origin. Okay, and such that initially 0 to 20 to 30 second, 20 to 30 second the velocity is increasing, but after that again its velocity is starting decreasing and it reaches at point this. So 0 to 10, 10 to 20, 20 to 30, and 30 to 40, and again it is reaching at point origin. So what is the change in that position? Initially it was at origin and finally it was at origin. So okay, the change in position is 0. That's why average velocity is 0. Okay, is that good?
Yes.
Yeah. So Now let's move in this problem. Solve this problem. This problem is actually very good. So what is the answer?
6.928.
How much?
6.928.
Okay, so what is in the irrational form? I mean in the square root?
48, root 48.
Yeah, that is correct. So you might be getting two values of v. I mean plus and minus. Why you are ignoring the negative values?
Okay, so should we say that also in the answers?
What?
Should we include that also, sir? Because it is complex, so would it be?
No, no, no. That is not the reason. Okay, I will explain. Okay, so here we already know that there is one more relation, and that is a equal to v dv by dx. Am I right? A equal to v dv by dx. V dv by, I mean in this case it is v dv by ds. Okay, so when you cross multiply things, you will get v dv equal to a ds. And if you take integration, then you can get that the area between a and ds diagram. Okay, so uh, when you can determine the area between a ds diagram, then you will get nothing but the area between v dv diagram, I mean v diagram. Okay, so if you want, if you integrate from the here from the initial velocity, because it is given that the particle's initial velocity is what, 0, and suppose if you want to determine the final velocity, okay, and here you have to do nothing because you are integrating a and s diagram from 0 to 12. So what will you get? 1 by 2 into this triangle, 2 into 2 plus 6 into 2 plus 1 by 2, area of this trapezoid. So 2 times 2 plus 4 plus 1 by 2 into 2 into 4. Am I right? And it is what? V square by Vf square by 2 minus 0. And what is this? This is 24, right? Am I right? It is 24, right?
Yes, sir, yes.
Yeah. So Vf square equal to 48, and you will get Vf equal to plus minus 4 root 3 meter per second. Okay, but here we have to ignore the negative value because you are getting two values. Okay, the reason behind this is you can see that the acceleration is always positive. Okay, and since the particle is in rectilinear motion and the acceleration is always positive and displacement is always also positive, so there is no chance that the particle's velocity is reversed, because if you take that the velocity negative, then you can check that the particle's direction must also be reversed. But here the acceleration is always positive. The acceleration is always positive. I mean to say that there might be chance that the velocity is decreasing. Here the velocity is decreasing, but still the direction of the velocity is not getting reversed. Okay, that's why we have to ignore the negative velocity. Okay, so the final velocity is what? 483 meter per second. Okay, is there any doubt?
Sir, I have a question from previous problem.
Okay, actually, I want to take 1 more hour because I have to finish. You know,
Okay,
is there
okay.
any problem if I
No,
want to take if 48 minutes more? Is there any problem?
No, sir.
no, sir.
Okay, okay. So let's move to the another topic, and that is relative motion of two particles. Okay, since I will discuss this in very short because I will explain in latter topic in very broad manner. So I will just define this here. So so relative motion of two particles. Okay, so if relative position if relative position of B with respect to A is xBA then xBA can be written like xB minus xa. And similar, if the relative velocity of B with respect to A is VBA, then VBA can be written VB minus VA. And same if the relative acceleration of B with respect to A is ABA, then ABA equal to AB minus AA. Okay, so this is the main fundamental thing of relative velocity or relative motion between two particles. Since I will discuss this in very broad manner, okay, but before going into that direction, I will talk about this. Sometimes the position of a particle of the particle depends depends on the position of other other particles. Okay, so what will happen? I will take one example. Okay, suppose there is a pulley, and in this pulley there is a mass A, and there is another pulley. Okay, and here mass is B. My writing is very bad. I'll draw this again. Okay, so here mass A and mass B, and I want to see the relative position between A and B, and also I want to see the the relative velocity and relative acceleration. So for that, what we will do? Okay, so that topic is actually called constrained motion. Constrained motion, not motion, constraint equation. So what we generally do in that? So there is a method where you you can assume that if string is inextensible, if this string is inextensible, which means that the length of this whole string is definitely what? Constant, right? Okay, now I want to see the relative position between A and B. So for that, I will assume suppose the relative position of, I mean the absolute position of, suppose the block A is XA. Okay, and suppose the absolute position of this pulley is, suppose, XB. Okay, so now I want to find this length. So what will you do? And also suppose this length is XC. Okay, now I want to determine suppose the point C. Now I want to determine the length L. So this string, what is the length of this string? That is definitely what? XA minus XC, right? Tell me. And what is the length of this string? XB minus XC, right? And what is the length of this string? That is XC, equal to what? Constant. Is there any problem in writing this? Because I want to write this length, I mean the length of this whole string, and here I am assuming that, suppose the position of this block A from this reference position, I mean from the reference line, is XA, and the relative position of this pulley from this reference line is XC, and similarly the relative position of this pulley from this reference line is XB. And now I want to find the length of this string. Okay, so the length of this string is nothing but the XA minus XC, and this length is what? XB minus XC, and this is what? XB, not XC. Okay, so now that is what? XA minus 2 times XC plus 2 times XB equal to constant, right? Now differentiate this equation. Differentiate this equation. What will you get? VA minus 2 times VC plus 2 times VB equal to what? 0. Are you getting with me? Tell me. Please respond. Hello?
Yes.
Yeah. Now you can see that here, since this pulley is not moving because it is connected by this arm, and since there is no velocity of this pulley, right? So definitely this velocity will become 0, right? But this pulley is moving and this block is also moving. So there is a relation between point A and point B. And here you can see that if I'm talking about the velocity of this pulley, it is nothing but the velocity of block B, right? Because this arm is fixed with this pulley. If pulley is moving with velocity velocity VB, then definitely the block is also moving with velocity B, right? VB, right? So here you can see that if the block A is moving in upward direction, then block B will be moving. I mean, if block B is moving VB in downward direction, then the block A will be moving 2 times with the velocity of VB, but in upward direction, because here VA is minus of 2 times VB. Okay, So here you can see that if this block is moving downward, then this block has to move upward, but 2 times of velocity of this block, right? And also you can get the relation between acceleration. Okay, now again differentiate, and you will get AA equal to minus 2 times AB. Okay, now let's move to the next topic, that is curvilinear motion of particles. Are you getting bored? Tell me.
No, no, sir. No, no,
Yeah,
sir.
should I continue?
Yes, sir.
Yes, sir.
Yeah, now let's move to the next topic, that is curvilinear motion of particle. Curvilinear motion of particle. Motion of particles. Okay, so what is the curvilinear motion? Particles move along a curve other than straight line. Okay, so that type of motion is called what? Curvilinear motion. Suppose you have coordinate axis like this. This is z, this is x, and this is y. And suppose at some instant of time the particle's position is r, and at time t, and suppose at time t plus dt the particle's position is r dash. Okay, so now connect this. If you connect this, that will become what? Delta r, right? Tell me. That will become delta r. Now if you want to determine the average velocity of the particle from point P to Q, what will you do? V average equal to what? Delta r by delta t. And now if you want to determine the instantaneous velocity, then you have to reduce the time interval, and you will get dr by dt, right? Dr by dt. Now I want to interpret one thing. Suppose you are reducing the time interval, right? You are reducing this time interval. Then what will happen? You are reducing the time interval. Then what will happen? This point will be getting closer and closer. Okay, this point will getting closer and closer. And when you draw this vector, it is r and it is r dash. Okay, and this vector is what? Delta r vector, right? This vector is what? Delta r vector. So definitely you can see that if you want to talk about the average velocity, then you can see that if the delta r vector is like this, then the direction of average velocity is also like this. Okay, so the direction of average velocity is also along the direction of this change in position vector. Now you want to reduce this time interval. Which is nothing but the P and Q. Then you will get that the point P and Q will be coincident. Okay, the point P and Q will be coincident, and the instantaneous velocity will become perpendicular to this position vector. Tell me, is there any problem? And this is nothing but dr by dt. So here you can see that the direction of derivative of any vector. If you want to see the direction of derivative of any vector, then you can see that The direction of derivative is nothing but the perpendicular to the direction of that vector. Okay, so here it is the important point. Suppose, so this is applicable everywhere, not here only. This is applicable everywhere. Suppose you have a vector. Suppose you have a vector function. So that is nothing but the vector of time t, and you want to see the value of p at each interval of time. Okay, you want to see the value of p at each interval of time. Okay, so what will happen? This connecting point is nothing but the curve, right? This connecting point is nothing but the curve. I mean this vector, this point is what? This vector, this the value of, this position of this vector, and if you connect each point, you will get a curve. Okay, now if you want to see what is the direction of dp by dt, then you will get that it is nothing but the at that instant of time you have to draw a tangent. You have to draw a tangent, and it is applicable everywhere. Okay, so at this instant, this direction, this tangent direction is nothing but the dp by dt direction. Okay, is there any doubt? So suppose similar case, you want to see what is the direction of a. Okay, that is nothing but the dv by dt. So suppose you are seeing that the velocity at each interval of time, the velocity at each interval of time, and by connecting all those vectors you are getting a curve. Now if you want to find the value of a or the direction of a, you have to do nothing, you have to just draw a tangent line. Okay, so that direction is nothing but the direction of acceleration. Okay, so you are getting confused. You may say that, sir, it means that acceleration is always tangential to the path. In general, that is not correct. In general, that is not correct. Here I am drawing velocity at each interval of time. Here I am drawing velocity at each interval of time. Like here I am drawing the vector p at each interval of time. So in general, acceleration direction is not always tangent to the curve. Here this curve is not the path. Okay, so you do not have to confuse. Here this curve is not the path. Okay, so in general, acceleration is not always tangent to the path. Okay, but acceleration is tangent to the what? This velocity. When you connect this velocity vector at each interval of time, then for that curve, the tangent is what? This acceleration, and the tangential direction is what? Acceleration direction. Okay, tell me, is there any doubt? Hello?
Yes, no.
Okay,
Yes, sir.
yeah, so is it clear or not?
So this acceleration direction alone.
What
This acceleration direction alone, can you please?
you are not getting? I am saying that here I already told you, here I told you that if we want to determine the direction of dp by dt, I am saying the direction of dp by dt, then that direction is nothing but the tangent to this curve, and I am saying that this curve is not path. Okay, this curve is nothing but the connecting all those vectors at different time. Suppose at time t1 the vector is p1, definitely you can locate everywhere. Okay, you can locate every vector, right? Suppose at time 1 second vector is I plus 2j, right? Then definitely you can locate like this, and different interval time the vector becomes 2i plus 3j, so that time is different, that time is this, that vector is this, and at each interval of time you are getting this point, these points. Now connect all those points. Okay. Now you want to determine what is the direction of dp by dt at this time. So you have to do nothing. You have to just draw a tangent at this point. Okay. Now you want to determine what is the direction of dp by dt at this time. So you have to draw tangent like this. That's what I am trying to say. But here you do not have to confuse. I'm not saying that acceleration is tangential to the path, because this is not the path. But definitely velocity is tangential to the path. Velocity is always tangential to the path, because for the velocity, v is nothing but what? Dx by dt. Velocity is actually derivative of path. Okay, so for the velocity, it is tangential to the path. But for the acceleration, it is not tangential to the path. For the acceleration, it is tangential for this curve, and this curve is what? The joining points of all those vectors at different interval of at different times. Okay, so in general, acceleration vector is not tangential to the path. Is there any confusion?
No, sir. Sir, actually, this concept is due to the centripetal acceleration, sir.
Oh, no, when I will talk about this. Okay, I will talk about this. I'm just trying to say that what is the direction of derivative? What is the direction of vector valued function? I mean, what is the direction of derivative of vector valued function? Because here p is what? Vector valued function. Okay, vector valued function. Okay, because it is a vector and it is a function of time, that is scalar. Okay, when you differentiate this, then that derivative, I mean the direct, because when you differentiate this, that is also a vector. Okay, so I want to ask, what is the direction of that vector? So the direction of that vector is nothing but the tangential to that vector path, not that path. Okay, not the displacement. Okay, I'm saying, is it correct? I mean, now are you getting or not?
Yes.
Okay, so now let's move further. Let's next topic is tangential and normal components. Tangential and normal components. Okay, so it is non-rectangular components. Okay, suppose there is a coordinate axis, and it is, in the coordinate axis there is a path where the position of particle at point P, where the position vector is r, and in the tangential direction, definitely it is the direction of velocity, right? And the velocity direction is nothing but the et, and et is a unit vector in the tangential direction. And here there is a normal direction, normal to this point, I mean this small arc. Okay, so for this small arc, the normal vector is en. Okay, so the designation of any position like this, I mean in normal direction and in the tangential direction, that is called what? Non-rectangular component. Okay, so suppose at point P, what is the position of the particle? Position of the particle is nothing but the mod of r, what? En, right? At point P, what is the position vector of particle point P? Mod of r En, right? Tell me. And the velocity of the particle is nothing but the v e t cap, right? Tell me. Hello? Hello. Hello.
Sir, what is that E, sir?
E E is nothing but a unit vector. In rectangular coordinate system, you usually write I, J, and K, right? Okay. But in this form, I'm not saying polar component. Okay, I'm not saying any polar component of polar coordinate. I'm just saying that there is one more coordinate system that is called tangential and normal components. Okay, so if you assume that the component which is normal to the this arch is called En, and when the vector which is tangent to this arch, which is called Et. So it is nothing but the unit vector to represent the direction. Okay.
Sir, means R bar's direction is generally given with respect to origin, and so En cap should be also along the same from O to.
Yeah. En is directly along the perpendicular. I mean, if this is arch, so this is the perpendicular. That's why I'm saying that this En is perpendicular. I mean, I'm talking about the particle at time t. Definitely, after certain time, the particle will reach at point t. So for that point, normal become this, which means that in rectangular component, I, J, and K direction doesn't change. In rectangular coordinate system, the direction of I, J, K never changes. Okay, but in in this system, the normal direction changes with respect to time t, and also tangential direction changes with respect to t. So that is the difference. Okay, but here I'm assuming that at every instant every instant normal is like this. And here it is not appropriate because I'm writing a circle. But in the I mean in what in curvilinear motion, at every instant of time, the normal to the arch, the direction is En, and the tangential to the arch you can take Et. Okay, it is just a orthonormal basis. This is what
Okay,
orthonormal
sir, means
orthonormal
in
basis.
case of polar coordinates, we.
No,
Hello, sir.
I'm not saying polar coordinate. Okay, I'm just
No, sir.
generalizing things. Yeah, tell me.
Means in case of polar coordinates, we have fixed directions, but in case of tangential and normal, we are going to have
In
changing
polar
with
in
respect to
polar
position of particles.
in polar coordinate, actually the r changes. The r changes in polar coordinate. The system is like this, but the curvilinear is like this. It is not following any straight line. Okay, polar is just things are everything at each theta. Things are constant at each theta. Just radius are changes at certain interval of I mean at each instant of time. But in rectangular, I mean in curvilinear motion, you can see that in En changes. En direction changes. Okay, and Et is also changing. Okay, so there is a difference. Obviously polar coordinate is also a part of what curvilinear motion. Okay, but curvilinear motion is a general thing. Okay, curvilinear motion is a
Okay, sir.
general thing. So here Et and En is a orthonormal basis. Definitely En is always perpendicular to Et, and the magnitude of En is what? 1, which is exactly equal to the magnitude of Et. Okay.
Sir, is it always necessary that the En will intersect origin?
En, no, I mean you have to fix the coordinate system. You have to fix it. Yeah, surely. I mean, suppose origin is a reference point, right? Suppose for this, for this arch, you can take that this is origin. Okay, This is origin. I mean, for the rectilinear motion, there is nothing like origin. In rectilinear, I mean, in curvilinear motion, there is nothing like what? There is nothing like origin. Okay, so at each interval of time, the En will intersect and at some different interval of time. I mean, at different point. But in polar coordinate, you can see that En is always intersecting at a common point. Okay, En is always intersecting at a common point, but in curvilinear, En vector doesn't always intersect at same point. Okay, so maybe the curve is like this. So for this arch, En is like this. So where it is intersecting? Okay, it is not intersecting. Okay, I'm just putting a
So
system. Okay,
R is to be taken from a different reference point for each position.
no, actually this is not a code. I mean, you are confusing, you are getting confused with this rectangular system. Here it is nothing like x and y. I'm not writing here x-axis and y-axis. I'm not writing x-axis and y-axis. Here r is not a polar. R is not a polar distance. Okay, it is like radius of curvature. Radius of curvature. It is not a polar distance. Okay, so do not get confused. Okay,
Okay, sir.
yeah, it is not. I mean, here I'm writing it is not a origin. Okay, is it good now?
Yes, sir.
Yeah, shall I move further? Okay,
Yes,
so
sir.
now here it is a v. Okay, so v can be written like v. Here v is scalar. Okay, so v et cap. Okay, now differentiate this. Now differentiate this. So dv by dt. So you will get what? D by dt v et cap. Okay, so from the chain rule you will get dv by dt et cap plus v d et cap dt, right? Tell me. So this is the dv by dt. Okay, so now the rate of change of velocity is nothing but the acceleration vector. So this dv by dt is called tangential acceleration, tangential part. Okay, now here it is a catch. What will you write? Det by dt. Okay, so here when you want to determine det by dt, then you have to use this. Okay, can you tell me what is this? Tell me. Can you tell me what is this?
पहला वाला माइनस ई है ना क्या?
Yeah, not minus. Here I am assuming this direction as a positive. This direction as a positive. So yeah, you can take that also. But here I am assuming this direction as a positive. So it is En. Okay. So I think the first time you have seen the derivative of unit vector. Am I right or not? So here,
Yes, sir.
yeah, det by dt, you can write v by rho En. Okay, here 1 by rho is nothing but the radius of curvature. Okay, so if it is a arch, okay, it is a delta theta and it is a delta s. Okay, when theta becomes very small, then it will become what? 1 by rho. Okay, so what is the acceleration vector? At et cap plus v square by rho En. So it is the general formula of acceleration in curvilinear motion. Okay, this is called tangential component, and this is called what? Normal component. Normal component. And you can see that the tangential component is due to the rate of change of what? Speed. Okay, because at here you're writing dv by dt, which is nothing but the rate of change of what? The tangential velocity. Okay, and v square by rho is coming into the picture because of what? Change in
Change of direction.
direction, due to change in the direction. Okay, is there any doubt?
Sir, what is it written on right hand side?
Here,
Again right hand. No, no, again right hand. The diagram you have given, a
uh,
small triangle shape diagram. Yes,
here.
yes.
Oh,
What?
actually, uh, if suppose the position is for this position, suppose is r1, and for this position is r2, and it is traversing, I mean the path is following from this point to this point, but changing the angle delta theta. Okay, so you already know that what? Theta equal to L by R, right? So here theta is nothing but the d theta, and it is a ds divided by rho. Okay, so here d theta by ds equal to 1 by rho when d theta, I mean delta theta, is approaching 0. When delta theta is approaching 0. So at the place of d theta by ds, I am writing 1 by rho. So it is a radius of curvature, this curvature. Okay,
Okay, sir.
yeah, theta by r. Okay, so now let's move to the radial and transverse component. Okay, so radial and transverse component. All these things are going into kinematic part. Okay, radial and transverse, radial and transverse component. Ah. Okay, sometimes you usually see that you have to resolve the velocity or position. You have to resolve velocity or position into two component, not only in rectangular component. You have also to resolve in radial and transverse component, and sometimes it becomes very handy. Okay, so what I'm trying to say that, suppose the particle is following this path. Okay, so at point P, suppose the position is r equal to r er. Okay, and here the direction vector is er, and the tangential vector is et. Okay, so I have already talked to you that if er, if suppose er is changing with by changing in the angle theta. Suppose the initially the er is like in this direction, and after traversing by angle theta, er becomes like this, er dash. So this vector is what? This vector is nothing but the delta er, right? And I know that the perpendicular of er is perpendicular of e theta, right? Perpendicular of e theta, and by rotating delta theta, it suppose it becomes e theta dash. So what is this vector? Delta e theta cap. Okay, so what can I write? I already written that the derivative of er cap with respect to time is what? Der divided by d theta into d theta by dt, right? and d theta by dt is nothing but what you can also write omega or theta dot der d theta is equal to what? E theta, right? And similarly, when you write e theta by dt, then you can write d e theta by d theta into d theta by dt, and again d theta by dt is theta dat,
ER
and it is er.
minus ER.
Okay, now here you can write minus er, because now here it is just the reverse of the previous er. Okay, that's why it becomes minus theta dot er. Okay, so we have earlier seen that v equal to what? Dr by dt. Okay, so d by dt, and r is what? R er, right? So after applying the chain rule, we will get dr by dt into er cap plus r d by dt er cap. So it is what? R dot, okay, and er plus r, and what is derivative of er? It is theta dot e theta cap, okay, and you will see that it is r dot er cap plus r theta dot e theta, okay. So this is called radial velocity, radial component of velocity, radial component of velocity, and this is what? Tangential component of velocity, tangential component of velocity. Now again differentiate this equation. What will you get? A equal to dv by dt. Okay, what will you get? R double dot, right? Er cap plus r dot er dot cap plus r dot e theta cap plus r theta double dot e theta cap plus r theta dot e theta cap. After simplification, you will get r double dot minus r theta naught square er plus 2 r naught theta naught plus r theta double dot e theta. Okay, and this component is called radial acceleration, radial component of acceleration, radial component of acceleration, and this is called tangential component of acceleration. When you study theory of machine, you usually see that this thing we call what? Coriolis component. What is the spelling Coriolis? Coriolis, I don't know. Coriolis, yeah, Coriolis component. Okay, so now I'm finding corollary. If particle is moving in a circle, then what will happen? R dot equal to 0 equal to r double dot, right? When particle is moving in a circle, then r dot equal to 0 is equal to r double dot. Then what will be the acceleration? This part will become 0. Okay, you will get r theta naught square er plus this will become 0, and you will get r theta dot. And you study this in circular motion, and you always say that this is tangential acceleration and this is centripetal acceleration. Okay, tell me, is there any doubt? Hello, please respond.
No, sir.
Yes, sir.
Yeah, now I will do one thing so that you can remember this equation. Okay, this is what? This is radial component, right? Suppose a particle is moving on a curvilinear motion. Okay, so what I'm trying to say that in this radial acceleration, r double dot is what? Particles radial acceleration. Okay, which is r double dot. Okay, and suppose the particle is moving along this curvature, then definitely there will be what? Centripetal component, or you can say what? Radial component. So what is the net acceleration? What is the net acceleration? Definitely r double dot minus what? You always study r omega square. Okay, so r theta dot dot square. Now there is also a tangential component. Okay, there is also a tangential component. So what will you do? At. Okay, and in tangential acceleration, there is definitely the change in velocity. There is change in a velocity. Now see this. No, yeah, there is a tangential component and change in velocity. So this is nothing but what? R alpha, right? This is R alpha. So R theta dot. Okay, plus there is also a Coriolis component. Okay, that is 2. You always study 2v omega, right?
2 omega.
Yeah, this is nothing but the 2v omega. Okay, so 2, or in simple term I write 2v omega, and in simple time writing ar is nothing but what? V, no, not v, a. Okay, so a, okay, minus what? R omega square. Okay, and at is what? R alpha. Okay, minus plus 2v omega. Okay, so now this becomes easy to remember. Okay, now see one problem. Shall I move to the problem? Tell me. Should I move to the problem?
Yes, sir. Sir.
Yeah, you are very familiar with this problem. Now solve this. But the difference is here you always see the problem in gate. You always see the acceleration. The acceleration is always a constant, but here the acceleration is varying with time. Okay, and also you always see the velocity of the slider along this rod is constant, but here the velocity is changing with time. Now nice, now solve this problem. You know, you might be thinking that I'm going in very difficult manner, but you know, this in this past year gate is getting very difficult. You know, you do not know what kind of thing they can ask. You can see that, but they surely they can ask anything. If this thing is in syllabus, then they can ask anything. Okay, first we need to determine the time, because without time you cannot find this problem, because it is asking at certain instant. Okay, so it is saying that after the arm OA has rotated through 30 degree. Okay, so when you put this 30 degree here. So what is the value of 30 degree? 30 degree means pi divided by 180 into
Pi by
30
C.
degree. Okay, so first you need to convert this. So when you put this here, what is it? Okay, so what is this? 0.15 t square, and you'll get t approximately 1.869 second. Okay, now let's move to the part A. In part A, it is asking the total velocity of the collar. Okay, so I'm not going through that formula, because that formula is not so easy. I mean, if you can remember, then there is no problem. But suppose you are not trying to apply that formula. So what will you do? R vector equal to what? R ER, right? So R vector, R is already given. So 0.9 minus 0.12 t square er. Okay, so it is asking to find the formula to find the velocity. So just differentiate this. So dr by dt. So what will you get? First you will differentiate this. So minus 0.24 t er cap. Okay, plus 0.9 minus 0.12 t square er dot. Okay, and at the place of er, what can we write? At the place of er, what can we write? Tell me. At the place of er, what can we write? Why you guys are not responding?
I didn't get it.
You're not getting here. I am saying that you have to just differentiate this, because it is already given this r equal to 0.9 minus 0.12 t square. How many guys you are? 14. Okay, more than sufficient. Okay, so here r is what? 0.9 minus 0.12. So definitely it is in the what? In the direction of er. So can you write like this? Tell me. Or you can also apply this formula, but I'm trying to say that do not try to apply this formula. Okay, because remembering things is not so good. Okay, you can also use this formula, but I am trying to say that do not use this formula. Okay, so definitely you can write like this. Okay, is there any problem here?
No, sir.
Yeah, now differentiate this simply, because it is asking to find the velocity. Okay, the velocity of the collar. Okay, just differentiate this expression with respect to time. So by applying the chain rule, first you will differentiate this expression and you will leave this er. Okay, then after that you will leave this and you will differentiate er. So what will you get? Er dot cap. Okay,
That is E theta into
yeah,
omega.
so minus 0.24 t er plus 0.9 minus 0.12 t square, and er dot is what? Theta into e theta, theta dot into e theta dot cap, right? Okay,
E theta dot cap नहीं E theta
oh
cap
yeah,
केवल.
e only e cap. Okay, only e cap. Now you need the derivative of theta. You need the derivative of theta. Theta is what? 0.15 t square. Theta dot is what? 0.3 t. Okay,
T.
now just substitute this. Minus 0.24 t er plus 0.9 minus 0.12 t square, it is 0.3 t e theta cap. Now put the value of t in this expression and you will get what? What is the value? 0.449 er plus 0.27 e theta cap. This is the value of the velocity. So this is the solution for part A. What is the solution for part B? I've already told you, okay, so if you want to determine the acceleration, first you have to find the radial component, which is AR, ER, and tangential component A theta, E theta. Okay, and I've already told you that AR is nothing but what? The acceleration in the radial direction. Okay, so R double dot minus what? R omega square. Okay, so what is the R double dot? R double dot here, so minus 0.24. Okay, minus
Point.
0.24. Okay, minus R omega square. R is what? Minus 0.9, minus 0.9 plus what? 0.12 t square, 0.12 t square. Okay, so it is R and omega square, and omega is what? This is the derivative. Okay, 0.3 t, 0.3 t. This is the radial component. Okay, and what is the tangential component? 2v omega. What is the tangential component? 2v omega plus what?
Around.
R alpha. Okay, so 2 times v. What is v? V you have already determined, right? V you have already determined, and no, yeah, V you have already determined. No, not this. Okay, V is actually the tangential velocity. Okay, no, not tangential velocity. I mean this slider's velocity. So that slider velocity is by derivative by finding the derivative of this. So minus 0.24. So minus 0.24. So you do not have to confuse. Okay, minus multiply omega. What is omega? Omega is 0.3 t, 0.3 t. Okay, so that is 2b omega. And now r is what? R is, it is already given, 0.9 minus 0.12 square, 0.9 minus 0.12 t square into alpha. Alpha is what? 2 times the derivative of this. I mean derivative of this, that is nothing but the 0.3. Am I right or not? I'm doing anything wrong? Tell me. 2v omega. Okay, and plus, oh sorry, yeah, minus r, which is already given, and plus omega square. Yeah, that is omega square. So 0.3 raised to the power 2. So you will get acceleration is approximately what? I already got that, 0.531. I mean in the radial acceleration is minus 0.391 er. Okay, plus that is also negative, plus minus 0.359 e theta cap, and the magnitude of the acceleration is approximately 0.531 meter per second square. And the third part is, it is asking the relative acceleration of the collar with respect to the arm. It is very easy. If it is asking the relative acceleration of the collar with respect to arm, you can see that this collar is always moving along this direction only. Okay, so the acceleration with respect to the collar, I mean the acceleration is, of collar with respect to A is nothing but the R double dot, and that is what? Minus 0.24. Tell me. 0.24 ER. And in the GATE exam, you always see that the velocity is fixed. I mean here you can, they can give that it is independent of time t, and the velocity is also independent of time t. Then you always get very simple answer. But here I gave it is as a function of time t, so that you can understand and you can get the feeling of this. So is there any doubt?
No, sir.
Yeah, you might be getting bored, but anyhow I have to
No,
complete
no,
it.
sir.
uh, in next week I will start Newton's second law. Okay, and you will we will solve very good problems. Yeah, someone, yeah, okay. Now I'm stopping the recording.